today we're going to take the next step on our ratio tables, and that's going to be comparing them. We're going to do basically have two sets of data in two different ratio tables, and you need to be able to look at them and try to understand how they're related. How many of you guys are familiar with the old saying, you can't compare apples and oranges? Okay? Basically it's saying if you have two totally different things, you can't really make a comparison. You have to have the same thing to make a comparison. And that's what we're going to be looking at today as we're doing this. So here are a few tips to help you. When you're going to be comparing the ratio tables, what you're going to do is you're going to look at each of the ratio tables and try to find a common entry. In other words, some place where they have the same number. Because if they have the same number in one area, then whatever they're comparing, we can now look at and see which one is different and how it is different. Yes, Liam? You know what is? We'll get there. You're a little bit ahead of me, but I like the way you're thinking. That's good. You're already processing this. Because what Liam's talking about actually comes to number 2, looking for an easy extension. So if you're looking at the numbers and you say, oh, wait, if I just do this many entries, I can get one that's going to be comparable, you can actually do that. So if I don't already have one, look for that extension. Your final method is going to be simplify your first set of numbers and see if they both simplify to a number that you can also compare. Fortunately, most of the ratio tables we look at today are set up so that they will simplify to the same number, but normally that's going to be more work than just finding a common entry, we'll put it that way. So our first one, we're going to do an example that's going to help you to understand what this whole process is about. So we have a 120-pound person. He would weigh 20 pounds on Earth's moon. A 150-pound person would weigh 28 pounds on Io, a moon of Jupiter. Use ratio tables, so there's some directions. We have to do this. We can't just do a tape diagram to determine which moon would make a person weigh the most. So there is our other piece of the task. We got to determine which one makes the person weigh more. Okay? Now this one gets a little confusing if you're not really thinking about what we're comparing. There's two things we're comparing. We're comparing their weight on Earth versus their weight on the moon, correct? So it's going to be, I'm going to use EW and MW, where EW is the Earth weight in pounds, and MW is the moon weight in pounds. And what we're really comparing is what happens on Earth's moon. So that's going to be labeled for my first table versus Io, or Jupiter's moon. Jaren, don't lean back in the chair. I told you you'd make it onto the internet. Yeah, Jaren, you know I'm talking to you. So now, I think it was Liam. What is going to be my first entry for Earth's moon? What was the Earth weight they gave us? The Earth weight. $120, and then the moon weight would be 20 pounds. Does anybody not see that? Okay, so just as we've been doing, to build my ratio table, all I need to do is show my work. I'm going to just do an additive to make it easy for myself. So I'm going to add 120 on the top. I'm going to add 20 on the bottom. Show your work twice so that I understand that you've got the concept. And then we can just keep going. So 360, I'm going to just keep adding 120, so that's 480. 600, 720, 840. 20 is easy, 60, 80, 100, 120, 140. So that should be the entire setup for your first table. Once you have filled that one entirely out, Now we're ready to begin work on our second one. Now our second one is a little bit different, right? What do we need on our second one? Madison? Okay, and 28. So this is going to be a little bit different because that's not an easy number to do, right? However, the concept is exactly the same. Now I'm adding 150 on top, adding 28 on the bottom, so that's going to make it 300, then 56. I'm going to add 150 on the top, add 28 on the bottom. That's going to get me 450 and 70, 84. So I'm just going to finish off the table. That's going to go then 600, 750, 900, 1050. On the bottom, adding 28 is going to get me 112. 28 will be 140, 168, 2196. So are these tables hard to make, guys? Honestly, especially, I mean, for me personally, looking at it from that additive aspect makes it easier because I'm not having to recalculate every single time. I'm literally just adding that number to the previous entry. Liam? How does 140 equal 120? Io? How did you figure that? Okay, what specifically did you compare? Okay, again, look for a common entry. In other words, somewhere I see the same number.
It's yours, by the way.
Okay. So you're saying because it's not at the end, it's... Well, that's the crux of this. Once you find the numbers, you have to be able to understand what they're saying and to be able to explain it. So I'm still waiting for the first part. What common entry did you find for both tables? Okay, is common to what? Okay, so you're saying you're focused in on this number here, right? Good. Because initially you said 120, which is not the same entry. That's what worried me. Yes. It's on video if you want to check it. I don't know how well it'll pick up your voice, but that is what you said. So here's one thing I don't like about this, and this is going to require some real critical thinking. What was our question? Jen? Which person would make the person weigh the most? So, a 140-pound person on the moon weighs 750 on Earth for Io. A 140-pound person on the moon weighs 840 pounds on Earth. So which moon made the person weigh more? Why? Isn't 750 less than 840? So why are you saying Io made them weigh more? Daniel? Excellent. Daniel did a perfect job of breaking it down. He did something that's actually really critically difficult on this problem. He understood that if I have the same weight on the moon, this person's only 750 on Earth. This guy's 840 on Earth, yet they weigh the same on the moon. So which one made him heavier? Io did. Now, an easier way to look at this would be to find an Earth weight that's the same. Is there an Earth weight that's the same? Which one? 600. So it would have been easier had you just looked at it on this one, because now it's really obvious, right? I have the same person, 600 pounds. The moon weight on the Earth moon is 100. The moon weight on Io is 112. Which one's heavier? So that one automatically clicks. So sometimes you'll want to look for more than one common entry based on what your question is. The question is actually really important because that's telling you how you need to interpret the data. Does that make sense to everybody? So our bottom line is, remember, we have a word problem, so we have to answer in a full sentence, is Io would make a person weigh more. The difference for a 600-pound person is 9 pounds. It's 12 pounds, sorry. So everybody understand that whole process? What we went through? Questions? So let's get some examples to help you understand this a little bit more. Okay, go straight across on page 42. We're down to 15 minutes. I'm not going to do example 1, but I think we can do number 2. So I do want you to be able to analyze these tables. So write a ratio to describe the relationship shown in the table. So what ratio should I write down? What do you think, Gunnar? What ratio does this table show? 2:16. Is that my final answer? I heard a lot of no's. Why not? What do I need to do? Yes? Simplify. I can divide both those by 2 to get me 1 to 8. So what ratio is shown in the table? 1 to 8. They're all equivalent to 1 to 8. Make sense? Okay. Now we're going to practice what we just taught. The following tables show how many words each person can text in a given amount of time. Compare the rates of texting for each person using the ratio table. So what we're really doing is comparing the rates. So we're going to rank them from fastest to slowest. So let's look at our first option. Do you see a common entry in between those tables? Liam? Okay, Jenna and who? Michaela, Jenna, and Maria. So is there a common entry somewhere where they have the same number on the same row? Jaren? Okay, so Jenna and Maria both have that 360, right? So who is faster, Jenna or Maria? Why? Good. So there's our easy comparison. We know Jenna beats Maria. Liam? Okay, Michaela and Maria both have what? 3. So I see a commonality at 3 here. Michaela's faster, right? Good. So we now know Maria's slowest, right? Because she lost to both of the other ones. So do we see a common entry between Michaela and Jenna? Does anybody see a pattern? Can we do an easy extension? Kind of like Liam talked about with the last one. Jen? Okay, how did you get that? Uh-huh. Okay. That's awesome. You're the first one in 2 days that's caught that pattern. So right there is an easy way to determine it, right? If you showed your work and said, how are these increasing? I'm going up 2 and up 100. If he's going up 2 and going up only 90. So that means Michaela beat Jenna. So can we now put these guys in order? Yes? So who was fastest? So Michaela was fastest. Then Jenna. And Maria was last. That's awesome. Okay, a couple other options. Because you threw that one out so quick, I didn't get to talk about a couple of other ones. One is an easy extension. You notice this is going up by 90 each time, right? What if I added 90 to 460 or 360? What would I get? Now I'd have another easy comparison, right? Okay, now your last one, and this one won't always work, but sometimes it will, and sometimes it is actually easier, is simplify my first number. So 3 and 150, what can I simplify that to? One and 50. So I'm dividing it by 3, right? So I divide those by 3. What about for Jenna? Can I simplify that one? I divide by 2. That gives me 1 and 45. And what about Maria? Divide by 3. 1 and 40. So we can see, if I simplified in this case, that would also be a great way to do it, right? Again, it won't always work. Sometimes it won't work because you don't get the same numbers in simplest form. But this is actually a really good method to use. It's just doing simplifying. Any questions on those comparisons, guys? Okay, good news. We actually have some extra time compared to some of the other classes. Okay, complete the table so that it shows the max has a texting rate of 55 words per minute. Now here's another interesting Engage New York piece. It says 55 words per minute, but then what did they put first on their table? Minutes. So what number would go with the minutes? They should be switched, but we'll go with what they've got. So what would go in the minutes? 1. What would go in the words? Make sense? So again, just be cautious when Engage New York is doing their quizzes and tests and stuff. Be careful that they don't mix them up on you. Make sure you understand that the order that they're written in should have translated, just like Gus said, I should have had words on top of minutes on the bottom in my chart. So that being said, though, can we still fill this table out now that we've got our initial entry? What am I going to do on top? Plus 1. What am I doing on the bottom? Remember to show your work at least twice. And then we can just finish it. 220. Is there anybody that's struggling on doing these tables? We went through pretty quick. We actually skipped a whole lesson on them. Yeah, because we felt that they're pretty easy. You guys have picked these up quickly. Making sense? Okay. Now, this next one's a little more complex, so we'll take some time on this one. So the tables below show the comparison of the amount of water to the amount of juice concentrate in grape juice made by 3 different people. Whose juice has the greatest water to juice concentrate, and whose juice would taste the strongest? Be sure to justify your answer. So we have two questions in here that we have to answer. And they gave us an additional task, put the juices in order from the juice containing the most water to the juice containing the least water. How do you determine the strongest? How do you determine what makes a juice taste strong? If I've got water that's mixed into it, what am I looking for if I want it to be strong? Less water, right? Because less water means it's less watered down. I mean, there's a reason we have that saying, right? If something is watered down, does it have a good taste or a bad taste? Normally bad, depending on how strong it started. But the one with the strongest is going to have the least amount of water in it. Does that make sense? So looking at our tables, do we have any common comparisons that we can compare these on? What do you think, Jared? They both have 15, right? Okay. And what are we trying to do? The most water. So which one has most water? Franca, Laredo, or Franca? Why Laredo?
Because he has 15, but he also has more heat concentration, which is still kind of liquid. No, wouldn't it be Franca? Because she has three juice, and if that means more juice would mean more strong, so that would be, it'd be Franca's.
So it's kind of like Daniel's reasoning on the moon. You're looking at the water, but I'm comparing the juice. If I want the one with the most water, then I want the least juice, because that means there's more water per juice. Make sense? So that means Franca actually beat Laredo. Okay? She's got more water than Laredo does. Okay, any other common entries? Gus, you find another one?
On Milton's and Franca's.
Okay.
They both have 40 in the water.
40 in the water. And who's stronger? Or who has more water? Franca. So she beat both Milton and Laredo. So we know hers has the most water, right? Okay. Now we need a common entry between Laredo and Milton. Do we have a common one? What do you think, Jaren? 20 and 20. Okay, that works. So at 20 and 20, who has more water? Milton. Yep. So can we now put them in order? Yes. So who's had the most water? Franca. And then Milton. And then Laredo. Okay. Now let's take a look. Explain how we use the values. We explained it on the tape, but basically we look for common entries. Then compared them based on who had more water. So what ratio is used to create each of the tables? The whole thing is a question. So while this is saying is take my first entry and simplify. So my first entry would be 12 to 4. How do I simplify? What do I divide by? Divide by 4, and that gives me 3 to 1. For Franca, her initial entry was 10 to 2. I can divide both those by 2, gives me 5 to 1. For Milton, his initial entry was, I can divide those by 2, gives me 4 to 1. Does that jive with what we said for our answers? Did Franca have the most water? Did Milton have the second? Laredo have the least? Good job, guys. Yes, sir.
In the question, doesn't it say whose greatest water ratio? Whose
point. We did not answer that one. So whose juice would taste the strongest? Laredo? Why? Least water. So I'm going to just add that one here. So Laredo's juice would taste strongest. Good job, guys. Making sure we didn't move on. Although you really ruined my thunder, because that was going to be something I pointed out once I flipped the page, so we hadn't answered them all. Way to pay attention. Make sense, guys? Again, the importance of boxing your questions, making sure you've answered everything before you move on to the next piece. Okay, so this is actually on your next page. Explain how the ratio could help compare to the juices. So once I have my simplified ratios, how could that help compare? Since there is a caveat on this, since they all simplified to 1, it made it easy to compare. Okay? So they all simplified to 1 and made it easy to compare the water content. Okay, since we're down to 3 minutes, we're just, yes? Uh-huh. Yeah, so you gotta do the other ones. Oh, I see what he's saying. He's saying if I had just divided this one by 2, I would have got 6 and 2. Then I'd have had a 2 in all 3 of them. And I'd have been able to compare 6, 8, and 10. Same thing. Good pick. Okay, let's go to the homework. Go ahead and turn to page 46. So we skipped all the rest of that. Okay, now, good news for those of you that were able to write all your notes down. Does number 2 look really familiar? Now, that being said, I do want you to recopy everything here. I don't want you just to say, see notes or something like that. I want to have it answered right here, guys. So re-answer it there. My suggestion, try to answer it without looking at your notes and use your notes to compare. Number 1, use the ratio tables to determine who the faster swimmer is. I'll give you a hint. Sometimes it's going to be easier to find that common entry just based on the numbers. In other words, what's twice 5? So if I doubled this, I could double this, and then I would have a common entry, wouldn't I? So your choice, but there's several ways to do it. You can also simplify, but part B, and don't forget to answer this, whichever way you choose to do it, explain it. Tell me what you did and why you did it that way. Okay? So a lot of kids answer the fastest swimmer. A lot of them forgot to explain the method. So please don't forget to do that. Any questions on your homework? Anything that we've covered today? Okay. You guys have about 2 minutes left.